if we start with 2 atomic orbitals, we need to end with 2 molecular orbitals. Let p orbitals to form a pi bond. This is going to follow directly from what we talked about in a previous video about overlapping s orbitals to form sigma bonds. So if you haven't watched that video, I've got a link below. You should probably watch that video first, as it gives you the background needed for this video. With that background in place, overlapping p orbitals to form pi bonds is really the same thing as overlapping s orbitals to form sigma bonds. Orbitals are just answers to math equations, so to overlap them, we use linear combination of atomic orbitals. We need to add these together constructively and subtract them destructively. So to add them together constructively, we would take one p orbital and overlap it with the second p orbital, such that all of the lobes are perfectly in phase. In the atomic p orbital, we have 2 lobes, one of positive phase, one of negative phase. So overlapping the orbitals of like phase gives us the most constructive overlap of these orbitals. That will increase the amplitude, increase the probability of finding the electron where these 2 orbitals overlap. So the pi orbital looks like this picture, where we have increased the amplitude of finding the electron, increased the probability of finding the electron in that volume of space between the 2 nuclei where the orbitals constructively overlap. This is the bonding orbital, and it is the pi orbital. Like with the sigma bond, this can't be the whole picture because linear combination of atomic orbitals says if we start with 2 atomic orbitals, we need to end with 2 molecular orbitals, but we only have 1 molecular orbital so far. We've already done the constructive interference, so now we need to overlap the orbitals destructively. The way we do that is like before, we add the negative, so we take 1 p orbital and we add it to the negative, where now the opposite phases of the orbitals overlap. When that happens, we carve out a space between the 2 nuclei where the probability of finding the electron will drop to 0, and we'll end up with a situation that looks like this, where we introduce a nodal plane between the 2 nuclei. The nodal plane is where the answer to the math equation is 0, where there is 0 probability of finding the electron. This is the antibonding orbital, and it is the pi star orbital. The linear combination of atomic orbitals allows us to take any 2 atomic orbitals and combine them constructively and destructively to create the possible molecular orbitals from that overlap. This is what a bond is. This is what it means to be a bond. The linear combination of those orbitals to make a bonding and an antibonding orbital. Whenever 2 orbitals overlap to form a bond, we always get 2 molecular orbitals out, 1 lower energy bonding orbital and 1 higher energy antibonding orbital.
Thanks for watching. If you like what you saw today, maybe let your instructor know about these videos, or your friends at other schools. Check out some of these other videos and playlists, see what you like. As always, don't forget to like and subscribe.